Hello my dear learners, I am Dr. Pawan Kumar Shukla and I am Professor in Electronics and Communication Engineering Department at RKGIT Ghaziabad, and I was giving the lectures of the subject antenna and wave propagation, and in my few of the last lectures I was discussing the various aspects of radio wave propagation. The different modes of propagation which are being carried out in the radio wave propagation are basically three, which are ground wave or surface wave propagation, sky wave propagation and space wave propagation. We were discussing all these three modes of propagation on the basis of their frequencies, on the basis of their requirements of antennas, on the basis of their applications, and the different kind of classification and discrimination can be held by using the different kinds of propagation. Some very specific modes of propagation are also occurred in the nature, in the atmosphere, because of the different atmospheric conditions. And as we all know that radio wave propagation is a phenomena, it is a mechanism which is based on the properties and characteristics of the atmosphere. So, we cannot rely the existence of the mode of propagation for a very particular kind of signals, for very particular kind of frequency range of the signals, and it is not appropriate to say that some of the modes of propagations will always happen for those particular frequencies or for those particular operations. So, my today's lecture will be based on some of the other kind of mode of propagation which are utilized in the radio wave propagation for some specific atmospheric conditions and for some specific operational frequencies of the signals in the radio wave propagation topic. So, I am starting the topic of today as different modes of propagation. As I was discussing about the sky wave propagation, although it is a very common type of propagation which was the extension of the ground wave or surface wave propagation, when we have utilized the frequencies up to 2 megahertz only in the ground wave or surface wave propagation. Definitely we are utilizing the frequency range at the higher version in the sky wave propagation, which is approximately 2 megahertz to 30 megahertz. This is the frequency range of sky wave propagation, means the electromagnetic signals of this frequency range can be used for sky wave propagation. It is very special from the point of view that it covers the longest distance between the transmitter and receiver on the earth. It means when the semi circumference of the distance is covered by utilizing any mode of propagation in this particular topic, it will be only the sky wave propagation. It can be only the sky wave propagation, because the semi circumference distance on the earth is the highest, is the longest distance which can be held between any of the communication link between a transmitter and receiver, and it is possible with the help of mode of propagation which is known as sky wave propagation or ionospheric propagation. In this kind of propagation, the electromagnetic waves are reaching to the destination point, first get reflected by the region of ionized gases in the upper atmosphere region, which is situated between 50 kilometer to 400 kilometer in the Earth's atmosphere, and this particular region between 50 kilometer to 400 kilometer in the Earth's atmosphere is also known as ionosphere. This mode of propagation is also called as ionospheric mode of propagation just because of the existence of ionosphere and just because of the utilization of this particular region of the atmosphere in this mode of propagation. The ionosphere acts like a reflecting surface and reflected back to the electromagnetic waves of frequencies between 2 megahertz to 30 megahertz. The process of reflection in the skyway propagation or ionospheric propagation is just because of the fact that ionospheric region is having the refractive index less than unity. The refractive index of the atmosphere in the tropospheric region is considered as 1 because it is known as the standard atmosphere, although just above the earth's surface it is not exactly 1, it is somewhat higher than the unity, and the refractive index gradient means dn by dh, which is considered as the gradient of the refractive index with respect to height. It is considered within the tropospheric region, and when we are going up in the atmosphere within the tropospheric region, this refractive index is decreasing slowly, very slowly, and it reaches up to exactly 1 at the height where it is called as the height of the standard atmosphere. Standard atmosphere is having the characteristic of refractive index as just unity. The electromagnetic waves of frequency more than 30 megahertz are not reflected back to the earth from the ionospheric, but rather these frequencies, these signals of higher than 30 megahertz frequencies are penetrating the ionospheric region. This mode is most effective between the frequencies from 2 megahertz to 30 megahertz, hence this mode is also commonly called as short wave propagation just because of the frequency range. With the skyway propagation, longest distance point to point communication is possible, as I have already told you that on the earth surface when the longest communication is established, we can utilize this skywave or ionospheric mode of propagation only. The main advantage of the skyway propagation is that in this mode of propagation the communication occurs with the help of multiple reflections of the sky waves, but these signals are affected by fading in which the strength of the signal varies with time. As the longest distance communication is possible, not only one single reflection process, the multiple reflections are occurred when the distance is too large, means when one particular signal is, suppose this is the curvature of the earth, and when these are the multiple reflections and these are the ionospheric region. This is the ionosphere and this is the Tx1 Rx1 and it becomes Tx2 and it becomes Rx2, then this becomes Tx3 and this becomes Rx3. So, starting from this to this means the communication links between Tx1 to Rx3, it is possible only with the help of skyway propagation or ionospheric propagation. So, simply This longest distance communication is possible only with the help of skyway propagation and ionospheric propagation. Next is space wave propagation. Why this space wave propagation is very common? Because it is a mode of propagation which utilize the frequency range between 30 megahertz to 300 megahertz, and I think this particular range of frequencies utilizes the most of the communication applications within this range, and it is used in FM, television and radar applications. In this propagation, wave propagates within the tropospheric, means just starting from the earth surface up to 20 kilometer maximum from the earth surface. And space wave consists of two components. First one is direct waves. Direct waves means the electromagnetic signals which are transmitted from the transmitter and reaching to the receiver directly. The communication between the transmitting antenna and receiving antenna is directly to each other, and when the signals are reflected from the earth surface and then they are reaching to the receiving antenna, this is known as the indirect signal. So, the combination of direct signal and indirect signal both are having their contribution to form an space wave propagation. At the receiving end, these waves may reach in phase or out phase depending upon the different path lengths. Obviously, when two types of signals are added at the receiving end, then they must be either in phase or out of phase, and this in phase or out of phase criteria is based on the path length. When path length is producing the phase difference and phase difference is just the result of the in phase or out of phase criteria. At the receiving end, the signal strength is the vector addition of the strengths of the direct or indirect wave, that because we have to get the resultant field strength at the receiving point. That is why we will calculate the final field strength by adding the vectors of direct and indirect electromagnetic waves. The space wave propagation is mainly used in VHF, very high frequency band, as both previous modes, namely ground wave propagation and skyway propagation, both fail at very high frequencies. So, obviously, space wave propagation is the mode of propagation which can be used for high frequency applications in the range of HF and VHF. Next one is tropospheric scattering propagation. This mode of propagation is very specific mode of propagation which occurs in the different circumstances, different characteristics of the atmosphere. And troposcatter, it is a mechanism by which propagation is possible by the scattered and diffracted rays. Scattered and diffracted rays are the responsible factors for the tropospheric scattering mode of propagation. The scattering takes place in the tropospheric region, and this mode of propagation occurs in VHF, UHF and microwave band when we are utilizing the very high frequency bands, ultra high frequency band and the other extremely high frequency band in the range of microwaves. UHF and microwave signals were found to be propagated much beyond the line of sight propagation through the forward scattering in the tropospheric irregularities. So, this is the resultant of the atmospheric irregularities which comes in the form of tropospheric scattering propagation. The mechanism helps to get unexpectedly large field strengths at the receivers even when they are in shadow zone. It is possible to achieve a very reliable communication over a range of 160 kilometer to 1600 kilometer by using high power transmitter and high gain antennas. we can utilize this with the help of high gain antennas, and the transmitted power should also be very high. The tropospheric scattering phenomena can be used to establish a communication link over a distance much beyond the radio horizon. When we are talking about the radio horizon, it is limited by the space wave propagation, which is known as the line of sight distance. And when this distance restricted phenomena of wave propagation is occurred, it is known only in the category of space wave propagation. And when we want to utilize higher frequencies for the communication, and we are restricted to use a very limited distance between the transmitter and receiver, which is known as line of sight distance, then we have to adopt some of the more useful mode of propagation, and this tropospheric scattering mode of propagation comes into this category when the frequencies are very high, and as well as the distance between the transmitter and receivers are also not restricted by the line of sight distance. The tropospheric scattering has been attributed to the blobs of refractive index changes and turbulence. The phenomena which occurred in the ionospheric mode of propagation is somewhat utilizing this phenomena here itself. Waves passing through such turbulent regions get scattered when lambda is large compared to the size of the turbulent eddies, and these waves scatter in all the directions. Simply this tropospheric scattering phenomena is shown in this diagram, and you can see here that some of the regions in the tropospheric range, they are specified for this kind of this mode of propagation. When the wavelength is small, frequency is very high, then the eddies, forward scattering dominates into the cones of angles alpha, and this angle is this angle alpha should be very small, and this particular angle is important to achieve for the tropospheric scattering propagation. And since the scattering process is of random in nature, the scattered signals continuously fluctuate in amplitude and phase over a wide range of frequencies. Troposcatter can be used to establish communication links in the UHF and microwave frequency bands. These links typically have a range of up to 1000 kilometers and can have bandwidths of few megahertz. So, it is a very important kind of modes of propagation which is utilized in the telephony and as well as the different applications in communication for the higher frequencies. It is very much useful for propagation in the range of 100 megahertz to 10 gigahertz. Obviously, this is a very wide range of frequency in communication. It produces undesirable noise and fading, which may be minimized to certain extent by diversity reception. Diversity reception is a very important concept in the antenna and wave propagation. Generally, in the communication, when we utilize the diversity reception, it for particularly diversity reception, we can design some of the antennas which are basically used for the purpose of diversity reception. Since the signal strength is like rhombic antenna, like many of the high frequency antennas are used for this particular application. The propagation exhibits seasonal variations. The forward scattering propagation is useful for point to point communications and radio or television relay links. The other kind of mode of propagation is known as duct propagation. Duct propagation is also a very specific and very elaborative in nature, because some of the atmospheric conditions which are abrupt and which are not usual in the atmosphere, when it happens, then such kind of duct propagation is happened in the atmosphere. The VHF, UHF and microwave frequencies are the frequencies which are neither propagated along the surface of the earth nor reflected by the ionosphere. Obviously, the frequencies range and the limitations of the frequencies under the category of skyway propagation, space wave propagation and ground wave propagation is limited up to 300 megahertz only. Then what about the frequencies above 300 megahertz? We have to adopt some of the modes of propagations which are utilizing these frequencies for the communication purposes, and the distance between the transmitting antenna and receiving antenna must be very much high, very much larger than the conventional modes of propagation which are limited up to line of sight distance or for the multiple reflections by the skyway propagation, and which are distances are limited by the ground losses. So, apart from all these conventional modes of propagation, this duct propagation is also a very important kind of mode of propagation which is utilizing the frequencies in a very higher range, and the distance can also be extended up to thousands of kilometers. But in tropospheric region, the and high frequency wave transmissions takes are reflected for beyond line of sight distance in this kind of mode of propagation. An atmosphere where the dielectric constant is assumed to decrease uniformly with height to a value equal to unity, at which air density is supposed to be 0, which is commonly called normal atmosphere or standard atmosphere. But in some of the specific conditions, the rules or the laws of the standard atmosphere does not follow in some of the range or some of the heights in the atmosphere, and when the general behavior of the atmosphere is not followed, some of the ducts are formed just because of the abnormal behavior of the atmosphere. In one of the regions, there is a region where dN by dH is negative, as I have already told about the refractive index concept in the tropospheric region. Obviously, when we go in the upward direction in the atmosphere, we see that the refractive index is continuously decreasing, and when dN by dH is negative, it means the refractive index is decreasing. In this region, the curvature along which the radio wave pass is slightly greater than that of the earth. Obviously, at the earth surface, the refractive index of the atmosphere is higher than unity 1. Due to this, the wave originally directed almost parallel to the surface of the earth, and it gets trapped in such regions where the temperature inversion is also a very important concept in the duct propagation. As we know that when we go in the upward direction in the atmosphere, obviously temperature decreases very rapidly and it is reaching up to minus 52 degrees Celsius at the height of the highest height of the tropospheric region. But in some of the areas, in some of the regions, it happens abruptly, like the temperature increases as the height increases. In those particular areas, the temperature inversion layer is formed, and just because of this formation of inversion layer, the duct propagation is happening. So, the concepts like line of sight and diffractions cannot be applied when the wave propagates through duct, and it is found that the energy travels by high distances round the earth without much attenuation. Some of the very important concepts in the duct propagation are taken by the atmospheric abnormal conditions and some of the abrupt behavior of the atmosphere. This is the diagram of duct propagation, where some of the ducts are formed just attached to the earth surface, means the abnormal behavior starts just from the earth surface, and some of the ducts are formed within the height range of height in the atmosphere in the tropospheric region, and these are known as ground based duct and elevated duct. Elevated duct are the duct which are formed within the tropospheric region for some particular heights. This is the mathematical concepts or some of the notations which are important to understand, and some of the calculations can be given for the kind of duct propagation, because it is a very specific kind of mode of propagation. So, these are some of the properties in the modes of propagations are not very much conventional, and some of the abrupt or abnormal conditions of the atmosphere is responsible for generating such kind of modes of propagations, but they are very much useful as far as communication is concerned. The different modes of propagation by utilizing the abnormal conditions of the atmosphere is also a very fruitful or very important concept in radio wave propagation. So, thank you very much for this particular video. In my next video, I will discuss the different parameters which are used for the skyway propagation. Thank you very much.